Hello guys, my name is Diego Pacheco and this is gonna be another Scala video. So this will be the part 3 and final part about Scala Tree. So if you didn't watch the other two videos, I recommend you guys watch it. So let's get started. Okay, so now on the previous video we stopped at named parameters and now we're gonna do on opaque types. This is cool, but this quite different, right? I'm still wrapping my head around this, right? But let's first talk how we would do things without opaque types, right? So often, and I code this for years and I still code like that, right? But let's give it Scala Tree a chance. But often what you do, you separate your types from your implementation, right? Like in SOA, you have a contract and you have an implementation. So in a contract in Scala often is defined by a trait, which is sort of like an interface in Java. And let's say if we were building a cache, right? So we would build a cache, say that's a cache of A. Let me do the Python instance, and then I'm gonna say, okay, so we're gonna have a get method where you will pass a key, which is gonna be a string, and what you're gonna get back, right? Let's call it key, is an A. And also, let's define a put, which, you pass a key and you pass A and you will get unit. So that's our interface or contract, right? Then if we would implement this, we would create an object. Let's say cache simple in memory cache, and this is in memory cache of A. Let's use it generics as well, and then I say, oops, I need to say this is from cache of A, and then sorry, this is an object. I actually cannot do that. If I want to do this way, I would need to put an abstract class here, but let's say it's for strings, right? So I actually gonna keep go here and say this is for strings. And then I would need to go here and say, okay, so what's the implementation of this and what's the implementation of this, right? And then we would say stuff like A is string, and I actually gonna omit the implementation to later on. String, and here I'm returning whatever as well, right? So let me just we also do override. We also do override here. Do override here as well. This means we are not implementing right now. Let me see now what I'm missing. It's extends. Oh yeah, and this is not A, this is a string. Let me just double check one thing here because I don't remember if I can do something like, I don't think I can. Can I do it? No, objects don't take generics, right? It needs to be a class or abstract class. So yeah, let's keep it as a string, right? Right, and then it's a cache of string, and that's it. Then on our code, we always would do something like, okay, so this is like my cache is the type cache of string, and then we would say, okay, so simple caching, blah blah blah, and here what I'm missing is just this. Yes, there you go. And then I would use my code, right? It go, my cache dot put, and let's say this is my key one, and then the value one here is like my value one cache, right? And we keep going. So the main point here is like we separate the interface, the trait, from the implementation, right? And the idea of opaque types is we're gonna do something similar. And we also gonna use type, right? So remember, type is an alias. So we are saying that we have a type called logarithm, which is a double. But this type is opaque. All right. So we're gonna have similar decoupling with much less typing. Because as you can see here, I don't have a trait, right? And then I can say, okay, so for logarithm, which is this here, which is actually double, right? So yeah, don't get lost. So logarithm, the type logarithm is a double, right? So logarithm, we're gonna receive a double, and we're gonna return a logarithm, which is another double, right? And we're gonna do math.logarithm, passing that double. And then here we're gonna do some extension, and we're gonna say, okay, for x, which is a logarithm, I wanna add a method to double, which there's no parameters, return a double, and I'm just gonna do math.exp with the double, and we're gonna override plus and multiply, so we can multiply and we can sum logarithms. Then on our application, we just import logarithms, right? And then we can just use logarithms here, and we can multiply them, and we can do for double, right? And I can run this code. You guys gonna see it work, right? I confess I'm still digesting this. So it's in theory, this is exactly the same thing. You have the same effect, but you end up typing less. And the magic is all about like the opaque word here, right? But I don't know if I like or hate it yet. But that's what we got. Then we have open classes, which is like as far as I remember, classes are closed by default, and when you say open, explicitly you're saying, well, this class, someone will add methods here and might be in some other file, right? And you can control that with that imports. In Scala, you control now lots of things based on if you have import or not. And here I create another class, star writer, where I extends writer, and then I have the send method, and then here I'm just calling it, right? So we are doing some extension here, right? And we could also do sort of with override, we could add methods, right? So open classes is just a way to say this class intentionally gonna be extended, right? It's a communication thing. Here, just playing with packages in Scala Tree, there is a cool thing where we have a package called users, and then I create two sub packages, administrators and normal users. And in admin, I have a class admin and a default value, which is admin. I have a class normal user and a default value that's normal user. And then on the application, you can, of course, import your package, but you can do hiding. Like this is you saying, okay, I want to import everything in Java util, and I know I want to do that because there is this underscore here. But because there is this weird syntax here where you have a type and sort of a function, it means that we are ignoring. So we want to ignore lists, we want to ignore maps, we want to ignore sets, and just want to get the rest, whatever's left, right? So that's interesting feature. I don't think I saw that in any other language. We have this other thing called structural typing, and I feel this is useful for sort of a binding, or sometimes you need copy and paste from one object to another. And that's what's going on here. And so we have a class, I call it person record, where we have elements as members. And these elements are pairs, right? So we have sort of a var arg here with pairs of a string and whatever. So I have a name and a value, and the value is any, so it means whatever, right? So we have like lists of tuples, right? And this extends selectable. And then there is a field called fields, where we just got the elements and transform in a map, right? Because we have key value pairs. That's why we can do this. And then we have this operation called select dynamic, where you pass the name of the field you want, and I'm gonna give you any, right? And then I'm gonna get that back to you. And then we have a type here, and this type is again is an alias, right? And the type of the type gonna be person, and the value of the type is gonna be person record, which is this class on the top. But here we are defining members, additional members. We are defining there will be a name, which is a string, and we're defining there will be an age, which is an integer. And this will fall down into the elements, right? That's what's going on here. So this is a cool syntax. And then here, I'm just creating a person, right? Which is a person record. And I'm passing the name and the age. All right. And then I'm getting back as instance as person, right? Because we have this type aliases. And then I have two ways to access the information. I can even access by person.name, or I can use the select dynamic and pass name, and also even get cast. This is how you cast in Scala. It's not even Scala 3 is old, as Scala 2 existence of, right? And we can run this. We can see the structural typing working. So that's structural typing. The next one is top level definitions. This is more like a DSL you can do. Like for instance, there is this enum called topping. Imagine like it's a pizza. And then we have cheese, pepperoni, mushrooms. And then we import the toppings. And then we have a class like the pizza. It has the toppings. It's just a array buffer of toppings. Then we instantiate the pizza. Then we add the extension where we looking for a string, and we want to add the method capitalize all words, where that string gonna be splitted by space. And we're gonna call capitalize and make this into a string. And here we are using capitalized word. And here we're saying that money is a type alias that is actually big decimal. And then here we are adding a topping, which is a cheese, right? And so we just add a topping to the pizza. And here we are printing the capitalized word. We could also print the pizza here. Pizza does not have a toString, so I will add it here so we can see what's going on. And I can either do this way, just gonna say toppings, or so to string. You know, there's a short syntax, like I think you can do something like this as well. Yeah, you see, we can do like this. So now I can run this code, and there we go, right? So this is not much like Scala Tree besides the Python syntax. It's more like showing how we can sort of do nice DSLs and stuff. Now we have something about traits, which again is something that Scala always had. It's not Scala Tree at all, but here's more like we seeing like the Python syntax, right? We have a trait animal, a trait has tail, then we have like a class that implements both traits, and here we just calling it, right? So this is like a pretty basic Scala code. Cool. Now we go to type classes. Type classes are cool because allow you to add methods on something that doesn't have like a method, right? Like for instance, we have a trait show, and show just returns a string, right? So imagine like you don't control this trait, or it's not in your library, or it's a third-party project and you want to do stuff but you don't have access here, right? So in that case, you create like a showable, which I'm gonna receive a generic, and then you do an extension of that A, saying that A has a show, and that show is a string. And here I have a person case class, which has first name and last name. And then we use like implicits that now are called given, and we have a showable of a person. So we transform a person in showable. And with, we apply extension to say, okay, I'm gonna get that person, and I'm gonna implement show, and the implementation gonna be first name space last name. All right. So it's just a fancy way to do extension, but the extension happens on showable. It doesn't happen on show, right? And then we have a person, and then we can call show from that person. And here we can have a method like show it all, where we can receive s that's showable, right? So the generic type s needs to be a showable, and we expect one parameter, which is a list of s, right? And the implementations, we're gonna call the for each on the list, and then we're gonna just call show on each element. And then I can say, okay, show all, and pass two different lists, and then we can see that happening. All right. So that's more like a different way to do sort of type classes with sort of a generics as well. Then we have like type inference. I was showing this a bit here, just I'm gonna explain a bit more, but like Scala can definitely figure out type. So like here, we know this is a string, so I either could do it something like this or just omit it and Scala figure out. Like here's 10, it could be the same as saying int, but Scala also figure out. Same here. I can even sum that two variables to prove that it's looking as an integer. Here I have a factorial recursive function, all right? And here I receive an int and I return an int, all right? And in this case, I need to express types, because if I do something like this, it doesn't work, because when you have recursion, there is a limit here Scala cannot figure out, and that's why here I need to type it, the type. So this is like something that the inference doesn't work. And here we have a case class where we have two generics, A and B, and we receive two parameters, X and Y, which is going to be A and B. And then I'm creating my pair, which is like a string integer 1 and the string Scala. And here just printing stuff. Here I'm creating a function ID that receives a t, and then the parameter will be x, that will be the type of t, and that I'm just gonna return it back, all right? And here I can call it, and then we can call this out. And all of those, they work, right? You definitely want to avoid this when you're doing nulls or any, all right? But otherwise, no, if it's not null, it's not any, it's not recursion, you can let Scala figure out for you. Now we are approaching the last things. So this is something I still kind of have mixed feelings. I don't know if I like it or hate it, but you can do type intersection, all right? And a type intersection is basically the ability to receive both types, and they don't necessarily needs to be on the same object graph or the same object hierarchy. So in Java or Kotlin or Scala, this language, when we want to receive like this type or that type, we often create like a trait or interface or abstract class on the top, and we made both implements. And then on our method or function, we receive the higher one, right? The interface or the abstract class. But you don't need to do that, right? So let's get down to that. So here we have a trait called resetable, where we have a method reset, and we have growable with some generic A, where you're gonna pass that A, and we're gonna grow, and there's no implementation. Then this is like the traditional implementation where, okay, so I want both, right? I want both it be resetable and growable. So I create both of A, and then I say, okay, I'm gonna extend resetable and growable of A. Then I have a method called callMe where I receive it both, right? And I want to be both of strings. Then I just call reset and add first, right? And then here I have my actual implementation of both, because both is a trait. And then I have do it all, and do it all extends both of string, and I implement both methods. I implement reset and add. And in reset, I'm just printing resetting, and in add, I'm receiving a string. I'm just printing that string, right? And then, like on this line 24, you can see I'm creating a variable c that's both of string, and then I just do it all. But sorry, in Scala Tree, you have these intersection types where you can do something like this. All right, so you can do that x is resetable and growable, and I could say, okay, and this is also let's say if I create x, all right. Oh, it also needs to be x now, and then, you know, it will not work because it's not x. And if I remove the x, well, now it works, all right. So you can in types or functions, or you know, you can expect more than one type, and these types, they don't need to be on the same object hierarchy. That's cool, but at the same time, you know, I don't know if it's a good idea, right? But anyway, that's what we got now. And let's go. We also have the opposite, right? And the opposite is called union types. And then in union types, if in section types is and, here is or. So what you do is like, let's say I have a case class username, which receives a string, and I have a password, which is a hash, hashing of string. And then I have my help method where I receive an ID. And this ID can either be a username or a password. And then I do a type matching. And if it's a username, I print something. If it's a password, I print something else. And whatever, I return an integer. All right. And that's the implementation. So here, as you can see, I'm doing help username and passing a username, right? And one other way to do this is you could create an enum, and then in your enum you have the possibilities, right? So that's not hierarchy. This is more like clustering the options together, which I think is a good idea. So we say, okay, so username, it receives like a username, password receives password. This is interesting when you know, they're not the same hierarchy, or they have completely different types to it. And then, you know, sometimes we need to do a inheritance with completely different things, just because that's the only way to pass them by parameters. So the cool thing about this is like, you don't need to do that. You don't need to go to the inheritance route. And you have this option, alright, that can be any one of those. Like I could even go here and say, yeah, I also accept a string. If you pass a string, for me, it's fine, right? Or, oh, I also want an int. Or, yeah, I want an int or a string. So if you pass username, password, int or string, wherever one of these four is good, right? So that's what you can do. And here, just showing like the second method where we cluster the types in enum. We import them, and then we just say here, yeah, I want a username and password, right? Because now it's all boils down to the enum, right? And then we can do similar thing. And here I'm just creating a variable, right? That I'm saying, well, this variable gonna either be username or password, right? So you can pass any one of those, right? And that works. So yeah, that's union types. Now, Scala also has universal equality, which is enabled by default. So in Java, when you have like this, right? Let's say something like this. In Java, if you have two variables, right, and you do something like this, you are comparing memory pointers, right? And if you want to compare types, you need to do equals. You need to do something like this, right? In Scala, as this was the case as well, we used to use equals, but now they copied this from Rust, and you can use derives, right? And one thing you can do is you can have universal equality, right? Like I have these two cats. Cat is just a string, right? Nothing special. And both cats are Melina, and I can compare them. And if you run this, you're gonna see they are true. And that happens because there is this derives can equal. But if I remove it, I think it also will be true because this is by default. Yes, as you can see, you either can pass derive or not. And that's exactly the Rust. But Rust is my like in the top here, you know, so it's more like an annotation, right? But it's the same idea. And there are other options we can do this. I have another example of a universal equality. You can enable or disable with imports, like I said. So we can have this like strict equality, where then you don't get that anymore. And you know, this is the derive example I showed you guys before. The other option is we can use given, right? And then a given we can send a given to can equal, which is like the generics, and then we can say, okay, a dog and a dog, they can equal, right? So you can do universal equality, all right? So that's it, guys. That's all the video series, the 3 videos about Scala 3.0. I am excited about new features and new capabilities. There are some things I left it out. There's probably like 5 or 7 other capabilities that Scala has that I didn't mention here, mostly because they are a bit more complex, and I might make a video about this in the future. Maybe not, let's see. And I just want to say that basically, you know, we have some shortcuts, we have some more flexibilities, we have some doubling down on types, and we have this Python syntax. Scala Tree is not out yet, so the ecosystem will need to catch up, which so far is not, right? But it's definitely a language to keep an eye on it, all right? So that's it, guys. I hope you guys like it. See you next time. Take care. Cheers.